Let's remind ourselves about what a surface is. Any liquid or solid consists of a bulk phase and a surface phase. The surface phase can be made of the same material as the bulk, in which case the surface atoms will be the same as the rest of the material, like in water. The surface atoms differ only slightly due to their exposure to the air. As you can see, in the 2D form, the bulk atoms have 8 nearest neighbours, whereas the surface atoms only have 2 nearest neighbours, so they are in a slightly different chemical environment. Also, some surfaces can be made out of a completely different material entirely, and they have been designed and engineered that way. There are many ways of making a new surface which is different to the rest of the material. Some involve plating or melting a new material onto the bulk or substrate, whereas some involve actually forming a chemical bond between the substrate material and the new surface being added. In this tutorial, we will look at various ways of producing a new surface onto an existing substrate, using deposition methods, such as painting, powder coating, spin coating, laser cladding, and electroplating. Then, in the next tutorial, we will discuss how we can form a surface using grafting, self-assembled monolayers, and plasma treatment, which are all methods whereby a chemical bond is formed between the substrate and the new surface. We will start with painting. Painting is possibly the most traditional and well-known way to make a new surface. Evidence of painting, particularly in cave paintings, dates all the way back to 30 or even 40,000 years ago, with oil paints formed with animal fats. Painting specific objects to change their surface is thought to originate in China in about 200 BC, using lacquer from trees. Painting became much more common throughout history, assisted by the discovery and development of oils and petrochemicals, and organic solvents in the early 1900s. Also, electronic machinery in the 20th century brought a transition from brush use to automated application of paint as an industrial technique. Paint is made of pigments for the colour, binders for mechanical and chemical properties such as drying rates, and solvents to disperse the components. Painting provides coatings to surfaces which are decorative and scratch, corrosion, and damage resistant. However, environmental drawbacks to painting have been recognised as a result of the volatile organic solvents used. As a result, recently solvent-free paints have been made available, as well as solvent recycling plants to reduce the waste produced. We will now look at powder coating. Powder coating is another method, like paint, of depositing pigments and binders to a surface. It has become more popular as the environmental drawbacks of the solvents in paints became apparent. The pigment particles in a resin are ground into a powder, electrostatically charged, and sprayed onto the object to be coated. Then the object is put in a curing oven where the powder melts into a smooth coating. Powder coating is arguably more cost-effective than painting, as there is no need to dispose of any harmful solvents, and it is more automatic. Due to the electrostatic attraction, the powder does not drip, leading to a wider variety of applications. Many products we see every day have been coated by this method, such as kitchen appliances, garden tools, and car parts, making up a huge industry. Now we will look at spin coating. Spin coating is a common method used to produce thin films of polymers on flat substrates. A polymer, dissolved in a solvent, is applied to a spinning piece of material. The spinning centrifugal motion causes the new layer to spread out to form a new surface, as well as making the solvent evaporate, leaving a thin, pure polymer coating. The thickness of the material can be varied according to how fast the plate is spinning. Here, a silicon wafer has been coated with polybutadiene, which was dissolved in a toluene solvent. A slight change in appearance of the silicon is noticed upon treatment. We will now look at electroplating. Electroplating is a method used to deposit a new metallic layer onto a substrate. It uses an electrical current to reduce metal cations in a solution into neutral metal atoms onto a plate. For example, here nickel is deposited onto a copper plate. As electrons flow around the circuit, the nickel ions move towards the plate, which is the cathode, so they are attracted to it. Here they gain an electron. The nickel 2+ ions in the nickel chloride solution are hence reduced to nickel metal and deposited onto the plate, changing the surface layer from copper to nickel. A star was drawn in marker pen, which would not conduct electricity, and hence no nickel would deposit there. After removing the pen with acetone, the distinction between where nickel deposited and where it didn't can clearly be seen. This is a very simple and common method of changing the surface to specific metals, and has many applications, such as preventing corrosion and rust of metallic objects. Now we will look at laser cladding and alloying. This is a method of producing a metallic surface on a substrate of different metallic composition. A wire or powder feedstock is applied to the surface of a substrate and melted on to produce a new layer by laser action. Like electroplating, this is a common method for corrosion prevention of metals. Low-cost materials can be coated with more expensive materials with more attractive appearances, such as coating low-carbon steel with stainless steel. Laser cladding is used to provide corrosion resistance for turbine blades in steam generators. In summary, we have looked at the features and applications of various ways to deposit a new surface on an object. While these are all relatively simple ways to get a new surface layer onto an object, these physical processes may not last as long as methods which chemically bond the new surface on. In the next tutorial, we will look at these chemically bonding methods, such as grafting, self-assembled monolayers, and using plasma.